Hey guys, today we're going to look at lesson 4, dilations, which I had introduced to you guys in class yesterday. So a dilation, I had talked about the pupils of your eyes for some time. A dilation is when you make a figure bigger or smaller, which the pupils of your eyes do get bigger and smaller depending on the amount of light. So in the top image here, just to show you what it would look like, I have a dilation, which the original triangle is in here, ABC, and then it's been enlarged. It becomes A prime, B prime, C prime. It's become bigger. So this type of dilation is called an enlargement. So this is a dilation called an enlargement. And then in the second example down below, I have A, B, C, D. The original parallelogram has now become smaller, A prime, B prime, C prime, D prime. So when it becomes smaller, it's also a dilation, but that type of dilation is called a reduction. So you have two ways that you can dilate. And we do this by using a scale factor. So the scale factor means that you're going to multiply. So you have the scale factor. Sorry, let me turn this volume down, these kids. In the first example, the scale factor is basically a number that you're multiplying all the coordinates by. So you're going to be multiplying by a number, a scale factor that is bigger than 1. Greater than 1. So your scale factor, that's a number 1. Your scale factor might be 2. Your scale factor might be 2.5. Your scale factor, so it could be a fraction. It could be 1.5. It could be 3. Any number bigger than 1, when you multiply by that number, it's going to enlarge your original figure. And then in the second example, in a reduction, your scale factor will be a number that you multiply also, but it'll be you'll multiply by a number that is between 0 and 1. So it'll be smaller than 1, but it has to be bigger than 0, because if it goes smaller than 0, it'll be negative, and you can't, that's not going to make the figure smaller. So it has to be basically a fraction or decimal between 0 and 1. Okay, so an example might be like 1/2, or 1/3, or 1/4, or 2/3, or 2/5. Any fraction that is between 0 and 1, when you multiply it, when you multiply by that number, it's actually like you're dividing it and you're making it smaller. Okay, so here are a couple of basic examples that we're going to be doing for homework tonight. If you look at example 1, graph the dilation of the figure shown using a scale factor of 2 and the origin as the center of dilation. Now, I had mentioned in class yesterday, you're going to always see this term, origin as the center of dilation. You can basically ignore it. It doesn't change anything that you're going to do. We're always going to be graphing dilations with the origin as the center of dilation. So just ignore it. Focus on your scale factor. Your scale factor is 2. That means we're going to be multiplying everything by 2. So the first thing you want to do is figure out what your coordinates are. Right now, A is at 1, 1. B is at 2, -1. Right? 2 to the right, 1 down. C is -2, 0. And then just multiply everything by 2. So everything times 2, times 2, times 2, times 2, times 2, times 2. So A prime will become 2, 2. B prime will become 4, -2. And C prime will become -4, 0. Be careful, 0 times 2 is still 0. And then you graph the new ones that you just figured out. So A prime 2, 2, 1, 2, 1, 2. A prime will be up here. B prime 4, -2 will be down here. C prime -4, 0 will be right on the x-axis. And then you just use a ruler. I can't make straight lines on this thing. And there's your new figure. Okay, and the scale factor of 2 told me that it was going to get bigger because that scale factor is a number bigger than 1. Now, if you look at example 2, it says graph the dilation of the figure shown using a scale factor of 1/2. So my scale factor of 1/2 tells me that this is going to get smaller. It's going to be a reduction. So first I'm going to list my coordinates. A is, what is that? 1, 2, 3, 4. 1, 2, 3, 4. A is at 4, 4. B is at 4, 5, 6, 7, 8. 4, 8. I don't know why I keep doing this thing here. 4, 8. C is at 6, 4. And D is at 6, 6. So we're going to multiply everything by 1/2. And remember, when you multiply by 1/2, you're really dividing by 2. So you could just kind of in your head divide by 2. So if you were multiplying by 1/3, just to like get you ready for homework, if the scale factor were 1/3, that's really like dividing by 3. If your scale factor is 1/4, that's really like dividing by 4. Okay, so you don't need to pull out a calculator. You can just still do it in your head. So A prime, if I multiply coordinates by 1/2, A prime will become 2, 2. B prime, half of everything, 2, 4. C prime, half of everything is 3, 2. And D prime, half of everything is 3, 3. And then I'm going to plot those points. So A prime at 2, 2 is here, A prime. B prime is at 2, 4. 1, 2, 3, 4. There's my B prime. C prime is at 3, 2. 1, 2, 3, 1, 2. C prime is here. And D prime is at 3, 3. 1, 2, 3. 1, 2, 3. So my new figure is like this. I feel like something's wrong. Hold on. The reason I know something's wrong is because the original shape and the new one should be the same shape, only just similar to each other. And this looks like it's changed shape. So let's see. A was 4, 1, 2, 3, 4. Becomes 2, 2. 1, 2, 1, 2. A is right. B was at 4, 4, 5, 6, 7, 8. Half of that is 2 and 4. 1, 2, 1, 2, 3, 4. Yeah, B prime I graphed too high. Okay, so this is good that you're watching me make a mistake, because now you can figure out how to know when something's wrong. It wasn't the same shape, so it was like longer at the top. So 2, 4. 1, 2, 1, 2, 3, 4. B prime should be here. And now that looks right. It looks like it's the same shape. Okay, and then just let me check C. 3, 2. 1, 2, 3, 1, 2. C is right. And D, 3, 3. 1, 2, 3, 1, 2, 3. Okay, one more example. All right, guys, last example. Oh no, 2 more examples, sorry. We're going to look at now, you know what? I have to switch this over to a new video. It's getting longer, so it's getting too long, the video. You won't be able to see it. So let me post this as a separate video. We'll do examples 3 and 4. Okay.